All right, in this lesson, we're going to use the scientific method to study two human diseases. One's called pellagra and the other cholera. In particular, we're going to be looking for the cause of those diseases. Now, this is the core of what science is all about, finding the causes of things. So before we get to the human diseases, let's take a step back and figure out what it is exactly that we mean when we say one thing causes another. We're going to use this working definition here. The definition for A causing B is going to have three parts. The first part, I think, makes sort of sense, common sense. A must come before B, right? So the cause has to come before the effect. Point number two, if A did not happen, B would not have happened, right? Think about that. If A did not happen, then B would not have happened. And third point, if A and B are not currently happening, then supplying A should lead to B. All right. Now, in a moment, we'll see some concrete examples. We'll put some real things in for A and B and see what that looks like. But just keep this definition in mind. This is very important because this definition of A causing B is going to allow us to come up with an experiment to test this hypothesis right here. All right, so from the very definition of causation, out of that definition follows the experimental design that is so powerful in science. But first, let's put some bones on these letters here. What do they mean? So let's take the example of the common cold. This poor guy here is suffering from a cold. Maybe this is him in reality. Here's the cartoon guy. Not a pretty sight over here. Here's a sneeze, right? And in that sneeze stuff, all those droplets are little viruses. So we now know that viruses cause colds. So back to our definition, let's see what it would mean for a virus to cause a cold using our definition. First of all, this guy was originally healthy, right? But then he got the virus. So the virus has to enter the body before the cold symptoms appear, right? That satisfies point number one. Secondly, if this guy didn't get this virus, he wouldn't be sick, right? That's point number two. If A did not happen, B would not have happened. And point number three is that if this guy was healthy, right, and then we give him the virus, he's going to get sick, right? If the virus really does cause colds, then a healthy person who gets the cold virus going to get a cold. Now, it's not, maybe it doesn't happen all the times. If you've already had that particular strain of virus, you might be sort of immune to that. But forgetting about those complexities, just the basic concept here is if this thing is causing colds, then giving a healthy person the virus should cause them to have a cold. Okay, so we can see then that the three-part definition here can be understood in the case of the common cold. So let's get back to the scientific method now. How does this definition of causation help us design experiments to test hypotheses? Well, testing hypotheses is the core of science. You can think of science as really hypothesis testing. That's what it is. It's a method to test hypotheses. Remember, a hypothesis is simply a statement like A causes B. It's a first attempt at an explanation. Explanations involve the concept of causation. For instance, a bacterial infection causes an earache, right? That could be a hypothesis. So here's the A and here's the B, earache. Many ear infections are actually caused by infections, and we have good evidence for that, but earaches can be caused by other things as well. Here's another example. Viral infection causes cold symptoms. We just saw that. But now here's the key. You see, from the definition of A causes B, remember our 3 points in our definition here. From that definition, it follows that one strategy for testing a hypothesis is to block the cause, as it is stated in the hypothesis. If A really does cause B, then blocking A leads to the prediction that B should not happen. And remember, a prediction is a statement about what will happen when you do an experiment or make an observation. Okay. So one way to test a hypothesis is to block A to see if B happens. The flip side is from point number 3. Remember, point number 3 was if A and B are not happening, then supplying A should lead to B. Well, that's going to be our second strategy. Another strategy in designing experiments is to supply A to see if B happens. In fact, a good experiment is going to do both of these things. You'll have one condition where you're blocking A and another condition where you're supplying A. So, what's an experiment? Well, since a hypothesis is usually a statement like A causes B, the A is what we'll call the variable, the factor of interest. It's what we want to know. Is it really having this effect? Is it causing the effect, right? Well, then the control condition is going to lack the variable. So that's the condition where we're blocking A to see if B still happens, right? The experimental condition has the variable. So that's the one where we're supplying A to see if B happens. And then, of course, we're going to compare the outcomes of those two conditions, right? We want to see if A really did have the effect that we predicted, that it would cause B. So right there is the basis of a good experiment. And you'll kind of see the conditions that you set up. Those conditions sort of are follow, or they are related to the very concept of A causing B. Right? In the control condition, we're blocking A to see if B happens. In the experimental condition, we're supplying A to see if B happens. So let's return to our case of the cold. So this guy here, so we can think about if we were to test the hypothesis that the virus causes the cold. Well, if we were to block the virus from entering the person, then we would prevent them from getting a cold. And on the other hand, again, right, if this person were healthy and we supply the virus to that person, then they should get a cold.